Okay, so scientific notation. This is what we use, or what scientists use, when they are talking about very, very big numbers or very, very small numbers. For instance, the size of a bacteria is a decimal. If you were doing it in centimeters, the size of a cell might be a very long decimal. Or the distance from here to the moon is what we would use scientific notation, especially if it were in inches. Okay, so here's the pattern for scientific notation. It's always going to be a number times the power of 10, where B and A are both integers. Now, this number right here has to be a number that's less than 10, but it can equal 1 or greater. Does that make sense? So it's a number. I'm going to have basically a number times 10 to an exponent. Okay, this number in here has to be between 1 and 10. It can equal 10. It can equal 1, but it must be less than 10.
Which box is that?
The big box right here. So this can be 1 or equal to or greater than 1. It can equal 1. It can be bigger than 1. But it has to be less than 10, not equal to 10. Do you understand the boundaries? Any number less than 10 and equal to 1 or greater. Okay? It can't be just a decimal like 0.9 or 9/10. It would have to be 1 and 9/10. Okay? And where A and B are both integers. Okay, so let's look at it. Here's the scenario. 6,320,000,000. How would I write that in scientific notation? I have to convert that number to a number between 1 and 10. So where is the decimal naturally in this number? Pedro?
At the end.
To the right or to the left?
To the right.
To the right of the last zero. That's where it is. So I place my decimal where it naturally is, even though it's not written. And I have to move this a number of places so it becomes a number between 1 and 10. Where would the decimal have to go to be a number between 1 and 10? Amanda? Between the 6 and the 3. So to do that, I need to move it 1, 2, 3, 4, 5, 6, 7, 8, 9. So now I've got my numbers 6 and 32 hundredths, 6.32, times 10 to the 9th power. Where did I get that 9? Mary?
The 9 jumps.
Right. The number of jumps becomes your exponent. Now, when I started this number, is this a whole number or a decimal? Yes.
It's a whole number.
So my exponent, is it going to be positive or negative?
Positive.
Right. Okay. This number, is it a whole number or a negative or a decimal? A whole number or a fractional amount?
Fractional amount.
So how do we show fractional amounts with exponents? Haley?
Negatives.
Negative exponents. Not just negatives. It's negative exponents. This time, to make it become a number between 1 and 10, where would the decimal have to be placed? Sabina?
In between the 2 and the 7.
Between the 2 and the 7. So I'm going to jump how many times to get it there, Sabina?
5.
1, 2, 3, 4, 5. So this new number, A, becomes 2.7, or 2 7/10, times 10 to what power? Sabina.
5 to the 5th power.
To the what?
The 5th power.
Be careful. This is a decimal. How do I show that with my exponent?
The negative 5th power.
Perfect. Okay. So we look at where it started. It's a decimal amount, so I have to show that right here. Questions? All right. I want you to do 59,000, and I want you to do this. Oh, here, let's do this one. 59 million. Can somebody tell me what to do to put that into scientific notation? Pedro,
Move the number from
the decimal.
the decimal from
Where is the decimal naturally?
the end of the right zero.
Okay.
To the right of the last zero. Then you
Right
move
here?
it To the yeah.
Are you sure?
No. Oh, to the in between 5 and 9.
Why is it there and not here? Why is it in between 5 and 9, not between 9 and 0?
Because if you put it right there, it would be another whole number.
It would be another, no. Why is it not here? Mary, why is it not here?
That's bigger than 10.
It's bigger than 10. It has to be a number between 1 and 10 in scientific notation. So I'm going, how many jumps?
1.
Pedro?
7.
7 jumps. So what's it going to be?
5 and to the 9.
5.9
9
times.
times 10 to the 7th power.
Perfect. Okay, you guys do the next one on your own. Pause the recording. What do we have for the large one? Yes.
Okay, so you have to move your decimal, and it will be all the way in the back on the right.
Okay.
And you're gonna move it. You're gonna move it 11 times.
Okay.
So it will be between the 1 and the 4.
And so what's my answer going to be?
So your answer is gonna be 1 and 4/10 times 10 to the 11th power.
Perfect. How many people got that? Good. Okay, we're in the right direction. With the smaller number, the decimal. First of all, knowing that we start with a decimal, what do we know about my final answer? Angela?
That's gonna be negative exponent.
The exponent will be negative. Okay, so I want to hear Ryan. How do I do this?
You move the decimal to the right
3
3 times.
times.
5 times.
1, 2, 3, 4, 5. Is that a number between 1 and 10? What? 42.6 is a number between
5 times.
1, 2, 3, 4, 5. That takes me to 42.6. Look. 4 times. To what? Where do you want it between? Between the 4 and the 2. Okay? And so what's my answer going to be?
It's going to be 4 times
4. You can't lose numbers. What else is there?
26.
Okay, how do you show that? 4.
4, 26.
No, how do we write that? Okay, Amanda?
4 and 26 hundredths.
4.26, 4 and 26 hundredths times 10
To the negative
negative fourth power. Okay, pause the recording and I want you to do the next one. Let's begin. Ryan, what am I doing?
You're going to move the decimal 6 times to the right.
Yep, 6 times. And what is the answer?
9 times 10 to the 6th power.
Good. Now, do you understand that when I have those, when I move the decimal, I'm just placing it there. I'm still writing this 4.26. Does that make sense? 4 and 26 hundredths. Okay. Now, this time, well, do you want to go on? Let's go on.
Yeah.
Let's skip these. Just more practice.
This is
More of the same. Okay, now we're going to go. This is called scientific notation. Now I'm in scientific notation. We're going to go to standard form. Standard form is how we normally see numbers. So I start with the number 1 and 9/10. Now, is this going to, in the end, look at this exponent. In the end, is this going to be a decimal amount or a whole number amount?
whole.
How do you know? I heard whole. How do you know, Amanda?
Because it's a positive exponent.
Because it's a positive exponent. So which way would I need to move this decimal to keep it a whole? Haley,
You're going to move it to the right.
to the right, how many times?
You're going to move it 5 times.
1. And every empty space, what do you think we're going to do? Jasmine?
Add a 0.
Add zeros. 2. 3. Add a 0. 4. Add a 0. 5. Add a 0. And I stop and my decimal stays there. Okay, let's try number 2. Number 2. Let's go with Isa here. Start with the number. It's going to eventually be a decimal, so which way do I have to move the decimal to keep it a decimal? To the left. How many times am I moving it? 7. 1, 2, add a 0. 3, add a 0. 4, add a 0. 5, add a 0. 6, add a 0. 7, add a 0. And then we always want to write that leading 0. Okay? Now, pause the recording and do 3 through 6. Your turn, Aset. So I'm going to...
You know it's going to be a whole number. So you have to move the decimal to the right 9 times.
Good. And so it becomes... How do we say that?
5 billion.
Well, this would be million, billion. 5 billion.
280 million.
Perfect. Okay, number 4, please. Jeanette.
Okay, so it's going to be a decimal.
Good. So I start with it, and then which way am I moving?
Left.
How?
Move decimal 10 times to the left.
10?
6 times
Good.
to the left.
And you don't have to say that. That's a big decimal. Tenths, hundredths, thousandths, 10,000ths, 100,000ths, millions. 341 millionths. Okay. Number 5, please. Samantha.
Okay, so you move
Is it a whole number or a decimal in the end?
a whole
A whole number. Which way is the decimal moving?
to the right
To the right. How many times?
8 times.
How do I say that?
600,000
No, 600
billion.
million.
Thank you.
Million. Okay, next one. Is it a, Sabina, is it a decimal or is it a whole number?
It's a decimal.
And what is that? Huh? Now remember, the decimal is naturally where? To the right or the left? The right. How many times are we moving? 1, 2, 3, 4, 5, 6. And start with our leading 0. Okay, now, forget about this. We're not going to be doing. Okay. Now, when we multiply in scientific notation, multiplying in scientific notation, this is where we use our rules of exponents. Number with number, like base with like base. So, we use our commutative property. Since it's 2 and 1/10 times 10 to the 8th times 1 and 5/10 times 10 to the 6th, I'm just going to use my scientific notation. My commutative property. 2 and 1/10 times 1 and 5/10. And 10 and 8/10 times 10 and 6/10. Okay? Now, I got to multiply those together. Yes, I have to do some decimal multiplication. So it is 2 and 1/10 times 1 and 5/10. 5, 10, add a 0, it's going to be 21. Now what? Angela? I have 2 decimal digits, so I'm going to go left 2 times. So this makes 3 and 15/100. Okay? And then what do you think I do with the other half? What am I doing with that? Mary? What do I do when I multiply like bases? Piper? We add the exponents. Please write that down. Like bases, do I multiply the bases? No. No, that was a rhetorical question. We are adding the exponents. And so this becomes 3 and 15/100 times 10 to the 14th power. Questions? Now, my bigger problem comes up with what happens when I multiply these numbers and my answer is not a number between 1 and 10. If I'm supposed to be multiplying with scientific notation, I got to make sure it ends in scientific notation. So, in this situation, like we know right away, 5 times 3 is 15. That's a number bigger than it's a number bigger than 10. So, here I go. I'm going to multiply 5 and 63/100 times 3 and 4/10. And I'm multiplying 10 to the 7th power and 10 to the 8th power. And that makes, when I multiply those out, I get this. Are you with me? When I multiply those two, I get 19 and 142 thousandths. Now, we're still adding our like bases, so what does that become? 10 to what power? Pedro?
10 to the 15th power.
That's right. So now, am I done?
No.
Why, Ryan? We got it. Yeah, we have to put it back into scientific notation. Now, here's the big thing to remember. Which way am I moving the decimal to put it into scientific notation? Angela?
To the right.
I move it to the right?
Because then it would be a whole number.
Huh?
Because then it'll be a whole number. Because it's positive.
Okay. What is the rule for scientific notation? Go back to the first slide. Shh. What do I know about A?
A is less than. No, A is greater than 1.
Or
Less than 10.
less than 10. So to move it to the right, is that number less than 10?
No.
So where do I have to move the decimal to put this in scientific notation?
One's to the right. Left.
To the left. Okay. Now, if this number, is that getting smaller or bigger?
Small.
If this gets smaller, I got to keep this in balance. If I make this smaller, I got to make the other side bigger by 1. I'm making this smaller by 1 power of 10. I've got to make this bigger by a power of 10. And so that will become to the 16th power. What if I made this smaller by 2 powers of 10? 2 decimal places. Yes.
2 things. That would be 17.
Right, it would get bigger by 2.
Yeah, and wouldn't it still sum up to the same answer?
Yes. It's the same thing like this, but this is in scientific notation. Now here's where your tests are going to try and fool you. They'll give you this and they'll say, write it in scientific notation. You'll get this answer and you'll leave it like that. If they ask for it in scientific notation, you got to give me the answer in scientific notation. Questions? Okay. Yeah.
Why did the 15 turn into 16?
Why did the 15? Because I'm moving my decimal here, making it smaller by 1, so I have to increase the power over here by 1. To get it into scientific notation, I got to make it smaller here, but I got to keep it in balance. So that one I'm taking, that what is it, power of 10 that I'm taking out, making it smaller by, I'm going to increase it over here. So it still stays the same, it's still as equivalent. Okay? Okay, one more thing, and then we'll practice. Hold on. Shh. Okay. Oh, actually, 2 different things. Oh, whoops. Shh. Hold on. Okay. Hold on. Shh. Let me also, okay. Sometimes also what comes up is division. Shh. So I'm going to make it basically, okay. So if I have 8 times 10 to the 4th power divided by 2 times 10 to the 2nd power. Okay. Again, I'm doing 8 divided by 2 and times 10 to the 4th power minus the 2nd power. Remember with division we subtract the exponents. So what does this turn out to be? Yes.
4 times 10 squared.
Right. Okay. Now, if I were given something like this, what if I have 32 times 10 to the 8th power over 16 times 10 to the 12th power. Okay? We take it each piece together. Pedro?
So you make it.
Oh, wait. Let me do this. Sorry. Let's make it 2. Okay? Pedro?
You make 32 over 2 into a fraction. Then you put times 10, and then you add the common base.
What do you mean?
Like you make it like that, like how you did it. Yeah, like that. And then you combine the like term.
10 to the...
10 to the 8, you subtract the 12.
Good.
And then it turns into -4.
Okay, so that's times 10 to the negative 4th power.
And then it's 16 times 10 to the -4.
Okay, now, am I in scientific notation? Ryan? So what do I need to do?
You have to move the decimal once to the left.
Go once over here. Is that getting bigger or smaller? That's getting smaller. So what do I have to do to the other one?
You have to add a 1.
Okay, so 1 plus -4 makes what?
-5.
There we go. Okay. One last thing to learn, Piper. Ordering. Now, I don't know. When you are ordering scientific notation, you have to actually write the numbers out in standard notation. So I'm going to have to move that which way? To the left how many times? 1, 2, 3, 4, 5. Okay. So I'm going to move that one to the left 5 times, and I end up with this. Then I'm going to move this one to the left 4 times. And then I'm going to move this one to the left 6 times. Now, take it out to the same amount of decimal places. Okay, like, this is what I do. So here you've got 4 more digits than I do this. Oh gosh, that's scary. Okay. Shh. There.
And there.
Okay, and then I just add my other numbers. Like I fill in those extras for me, so they're all equivalent amounts. Okay, now what I compare basically is this. Okay, you tell me the biggest number. What's the biggest number? Sabina?
4.3.
Yes, that is the greatest number. Now, they said from greatest to least, so we're going to write this number first. 4.3 times 10 to the negative 4. Then, the next biggest number. Pedro.
3 to the 4. No.
3.4 times 10 to the negative 5th. And then the last one would be 7.09 times 10 to the negative 6. And now, please stop. The most important thing is you go back and reread those directions and make sure they want biggest to smallest or smallest to biggest. You do that in the beginning and you do it at the end and double check yourself. All right. Piper. Oh.